Good afternoon, everyone, and welcome to session 5 of the IRF 2025 annual conference, Digital and Automated, the Next Era of Roads. It's a pleasure to be with you today, and thank you for joining us from across the world to talk about this critical topic. At the International Road Federation, our commitment extends beyond building safer and more resilient road systems. It's also about preparing roads for a digital, connected, and automated future. Thanks to our programs, ranging from digital readiness assessments and smart infrastructure standards to capacity development and policy guidance, we help to translate cooperative, connected, and automated mobility, otherwise known as CCAM, into practical strategies that can be implemented worldwide. We work to ensure that digitalisation, AI-enabled traffic management, V2X communication and automation are not just technological concepts, but are also embedded in road planning, governance, and investment decisions. By supporting countries at all stages of development, we help shape the evolution of roads as active enablers of connected, cooperative, and sustainable mobility systems. Digitalisation is reshaping how roads are built, managed, and used, opening the way for vehicles, infrastructure, and people to be seamlessly connected. From vehicle to everything, V2X, communication, and AI-enabled traffic management, to automation and data-driven mobility services, cooperative, connected, and automated mobility represents the frontier of road innovation. These technologies have the potential to improve safety, reduce congestion, and make road systems more efficient. But they also raise new questions about investment, interoperability, and public acceptance. This session is going to look ahead to how CCAM can transform the road sector in the coming decade. It will explore how digital tools and automation are evolving, what opportunities they bring for smarter and safer mobility, and how governments, industry, and cities can prepare for rapid technological change. By focusing on the road sector's role in shaping and governing these innovations, the discussion will highlight how roads can evolve alongside the world's new technology to deliver more connected, cooperative, and sustainable mobility systems. Today, we have the honor of welcoming a group of expert speakers representing academia, industry, research, as well as global partnerships. I'm not going to read their full biographies, as these were rather long, but I am going to briefly introduce them in the order that they are going to speak today. First and foremost, Professor Bin Ran, Professor and Director of the ITS program at the University of Wisconsin at Madison. Siddhartha Kastgir, Head of Safe Autonomy, Warwick Manufacturing Group and the University of Warwick. Tom Arkim, Strategic Advisor for Connected and Automated Mobility at MapTM. Ibon Arralde, CEO of Asimob, and Jorge Suarez, Project Manager for the Department of Technology at ATRA. We're going to begin with 5-minute opening messages from each of the speakers, who have all kindly agreed to limit the number of slides that they're going to share before we move into a moderated discussion and questions from the audience. Professor Bin Ran, if you would like to begin.
Sure. Yeah, it's a great honor and happy to be the speaker here and also talk in 5 minutes. And so I'm going to talk very briefly in terms of how the AI empowering the integration of connected autonomous road infrastructure and vehicles together. And page 2, please. So I'm going to talk about 3 aspects. First, in terms of the designing and also deployment trend. And I think we're using different terms here. However, I'm going to give a few perspectives. For example, and when we start to see the integration in the next 5-10 years, or even down the road for 20 years, so we see more and more coordination and integration of connected autonomous road infrastructure and vehicles in the full life cycle in terms of design, development, and deployment, construction, operation, and maintenance. We are mingling together many terminologies and also the way of doing business. So we believe a full life cycle approach will be used by both the road infrastructure industry and also the vehicle industry all together. And the third point is we will see a very substantial and significant expansion of the components in terms of digital road infrastructure when we compare what we have here in terms of IRF today. For example, traditionally we included roadway and control devices, signing and marking. However, we are gradually and probably will be making more inclusion of the digital map, the cloud, the edge servers, roadside computing, communication network, energy systems. They will become part of the expanded definition of digital road infrastructure, will be included in the future operations of the roadway infrastructure when we move on to the CCAM here. And point number four, we will see a very substantial increase of value in terms of the digital infrastructure for the infrastructure when we compare with the physical road infrastructure. So currently, for example, although it's a hard number to figure it out, however, we can safely say there'll be somewhere like 80%, 90% of the weighting or relative value in terms of the physical road infrastructure. However, the relative value in terms of digital infrastructure will be relatively small. We're talking about maybe 10%, at most 20%. However, into the future in 10, 20 years, we'll see the value of digital road infrastructure will increase to somewhere like 20% or 30% or even 40% in the future. So as a road operator, we'll see a very substantial change in terms of mentality, thinking, and logic. And in terms of traditional AI and other IT areas, the number has already changed. In the US, we have already seen that 70% versus and 30% between digital and physical. And in roadway infrastructure, this will be one of the last areas where see the changes happening. And next, please. So in addition to the design, inference deployments, and we are moving to, for example, operations and maintenance trend as we see into the next 5, 10 years. And we will see the gap between the full life cycle of connected autonomous road infrastructure and also the life cycle of connected roadway, connected autonomous vehicles will be substantially reduced. So in the vehicle industry, we have seen the life cycle of 7 years to 5 years. Now for EV, for example, we see the somewhere like 2 years, at most 3 years, you see a full new EV or even hybrids. And well, although for physical road, it's hard, and we're going to change the life cycle of a bridge or tunnel or roadway in somewhere between 20, 30 years to down to 10, 15 years. However, the digital side of the infrastructure, especially roadside equipment, we'll see a very substantial reduction. So somewhere like 5, 10 years. And then we'll see a more reduction in terms of other computing devices, clouds, edge, etc. And in addition, we see the trend of newcomers or transformation of commerce. So we see lots of new operators of CCM here will start to dominate the value chain of the whole industry in terms of both road infrastructure and vehicle industry. And we'll see the integration or integrated operation of the vehicle industry, road industry, as well as the energy sectors. And they will become the major player at the center stage. Next, please. So in addition to those two trends here in terms of design, operation, maintenance, and operation, we'll see a very large influence of AI. We know now this is a time of AI. However, how are we going to bring that into our daily operation and design of the roadway infrastructure? We see the following is going to happen. And traditionally, we see the vehicle along itself is playing as a major player in the center stage. However, we start to see more and more distributed intelligence based on vehicle road or vehicle road cloud or vehicle cloud architecture. We do believe that's becoming a main option for the AI-empowered high-level autonomous driving. We started to see that happening in terms of, for example, in the US, and also I'm sure in Europe, as well as Asian countries such as China and Japan. And as we see more and more deployment and market penetration of AV, and also the requirement for reducing the latencies and time to response for rapid computing. So the edge computing or roadside computing will become inevitable because clouds are very, very scattered distributed in any of the continents. And then the road vehicle or the vehicle cloud, although the vehicle cloud architecture is to become a very essential choice for level 3, level 4, or level 5 autonomous driving itself. And in addition, we see the major application of AI in the next 10 years, especially AI large models, based on the matter it's Jason Huang or Elon Musk. We'll see it's one of the top three applications and the autonomous driving itself. So in this center stage of playing of the AI playgrounds, we see the vehicle world cloud architecture will be requiring the capability of AI large models. We'll see a very nice integration into not only the vehicle side, but also into the infrastructure side as well. So we will provide an efficient platform for training, inference, deployments for current level 2, level 3, or level 4 vehicles, as well as for the system itself. We'll see a lot of more distribution and sharing of intelligence for intelligent driving between the vehicle and roadway infrastructure. As a matter of fact, the SAE is releasing a new standards, J3316, and it's going to support that definition, and which is a major improvement and also elevation of what we're talking about here today. Okay, thank you.
Thank you very much, Professor Ren. Thank you. That was very interesting. And I look forward very much to going over some of that in detail during the question and answer session.
It's great. Thanks.
Thank you. If I may, I'd like to introduce Siddhartha Kaskia.
Thank you so much, Iona, and thank you for the invitation to talk today at this forum. Absolute honor and a pleasure here. So I'm going to talk to you about how do you actually enable safe automated driving in the real world, not in the imaginary world, and what would it take to actually enable them. So next slide, please. So I've been working on this automated vehicle dream for the last, I would say, around 12 years. And when we started off back in 2014, 13 on time frame, it was more of a sci-fi world. And we thought we could actually see cars driving on their own. And fast forward 2025 or 2024, if you might say so, if you go to the next slide, please. Now we actually have real vehicles with real autonomous tech in them on public roads. Yes, it's siloed in certain geographies. It is siloed in for certain communities. Also, I see a question also in the chat around this concept, and we'll talk about that during the discussion. But we do see now the technology on our roads. So it's no longer the sci-fi. So as a academic, as a researcher, having worked on this technology for the last 12 years, it's a kind of a pivotal moment, an inflection point on our journey for automated driving. So that's the reality. So it's no longer the philosophical or sci-fi approach. It is now real on public roads. But there is also an additional reality that most of us in this ecosystem don't want to either accept, or we don't talk about that a lot. So the other reality is that if you look at any SAE level 4 automated driving system. So for those of you who are new to this terminology, SAE level 4 means that you don't have a driver behind the steering wheel and the car can drive on its own and can stop if there's any failure on its own also. So for any SAE level 4 automated driving system, across the board, be it in the States, be it in Europe, be it in Far East, wherever you see these deployment, they need some level of remote support or some level of external support. And we'll talk about these two terms in a minute in a bit more detail. So there is a need for remote support and external support. So, and this is a concept that we don't talk about a lot. When we go into the normal conversations, we like to focus on the bright and shiny pictures that you see, but there is this need that is there in order to ensure the safe operation of these technologies. So what is the issue right now? So we all accept there is a need for remote support. We accept there is a need for external support, but we do not have robust or agreed upon requirements either at a policy level or at a standards level to actually ensure that every stakeholder and every player in this automated vehicle ecosystem understands what level of remote support is needed. How do we actually ensure the safety of the remote support, which essentially is needed for the safety of the vehicle, automated vehicle also. And this concept that the remote support could be, and in most cases would be, human, but the external support could actually be infrastructure. Now, this is a very important construct here. So when you are operating an automated driving system or automated vehicle like the ones that you see in front of you, all of them have lots of sensors on them, all the way from cameras, radars, ultrasonics, lidars, and so on and so forth. However, there is a construct and a configuration where you could accept information from external sources. For example, information like weather information coming from infrastructure, or information about roadworks coming from the infrastructure as an external source. And that information, together with the onboard sensing information, can be very beneficial to ensure and maintain traffic throughput for the system. So it's not just about the sensors that are on the vehicle. There is a benefit, a potential benefit, by sourcing information through off-board sensors, essentially on infrastructure. And that's the concept of external support. Now, together between remote support and external support, you could actually have a very safe and an efficient automated driving system. So most of these systems that you see in front of you, you've got the Waymo on the right, you've got the Zoox on the top, and then Wave on the bottom. Most of them, not most of them, all three of them have some level of remote support involved. So when you sit, if you have had a chance to go and sit in any of the Waymos, you can actually press the button on the dashboard and talk to a remote support person in the remote operation center. And the same would hold true for the other two also when they are commercially there. So if you talk about these concepts of external support and remote support, what does it mean when it comes to at an engineering level? Next slide, please. So those are the challenges, but now what do we do in order to actually address them? And I think we'll unpick quite a few of them through the course of this webinar. So I think the first thing is, let's accept reality and let's accept the facts associated with reality. Just because the tech exists doesn't mean the enabling infrastructure required for the tech is not needed. So as I've just highlighted, for all SAE level for automated driving systems, you will always need remote support. So that's the first thing. Second thing is something that we've been working on at WMG at University of Warwick, together with our colleagues MapTM and Trafficon in Finland and the European Roads Association. We come up with this concept of distributed ODD attribute value awareness, or in short, DOVA. Now, this essentially is a concept, a slightly technical word to say the same thing as I said about external support. So essentially, DOVA means that sourcing information from external sources like infrastructure for information for weather or traffic issues or roadworks. So those are the kind of information that you can actually receive from infrastructure, and that will help the system to understand how to route the vehicle, or how to actually profile its speed trajectory. And to address these gaps of not having standards and not having agreed requirements, there's a lot of work that has been initiated right now. It's not yet fully published, but there's work that has been initiated at the ISO level, at international standards level. So ISO TR 17720 is actually focusing on how do you standardize the external support aspect. And a new ISO has been initiated as to how do you standardize the remote support aspect. So while I gave you some of the challenges that we've had, the ecosystem has actually come together to address them. And I think the biggest success over the last 12 years, I would see, of the automated vehicle ecosystem is the spirit of collaboration. And that spirit of collaboration needs to be continued, needs to be strengthened to get to a safe deployment of automated driving systems, not only in the silos that they exist today, but in for in other countries and other communities also. So that's all from my side. Thank you again, and I'm looking forward to the conversations during the course of the webinar.
Thank you very much, Siddhartha. Thank you. That was also fascinating, and I look forward to going over it in some detail afterwards. If I may, I'd like to introduce Tom Arkim.
Yes, thank you. My name is Tom Alkim from the Netherlands. I work at a company called MapTM. But before this, I spent more than 20 years at the Dutch national road operator called Rijkswaterstaat. And we spent a lot of effort on automation from the perspective of the road operator. I also spent 3 years in Brussels at DG Research and Innovation working on CCAM. And I've had the pleasure to accompany the former speaker, Siddhartha, in his first fully automated drive in San Francisco. And we have fond memories of that experience. Next slide, please. So I was asked to give an overview of what we do in the domain of CCAM. We do a lot of international and national projects, internationally both funded by Horizon Europe, but also by CEDAR, the Conference of European Road Directors. I was recently also appointed as co-chair together with Bin Ran of the IRF Connected and Autonomous Mobility Committee. Within the CCAM Association, I'm the delegate for physical and digital infrastructure. And back home, I lead several knowledge sessions on CCAM. I'm on the International Advisory Board of Intertraffic, and I am the chair of the International Task Force for Vehicle and Highway Automation. I put a picture here to see in what kind of projects we are active, and you can see that they are scattered along several of the clusters. And these clusters all represent a certain type of element that is needed to have successful deployment of CCAM in reality, because it is not only about the technology, it is also about safety assurance, convincing authorities. It is on acceptance, on doing things in practice, and integrating these technologies and services in the current systems. So there's a lot of different multidisciplinary challenges that need to be tackled before you can have actual meaningful and responsible deployment. And that's why collaboration is so important, as Siddhartha pointed out. Next slide, please. As an example of what we see in the future, the role of the road manager and the road operators, there will be a digital transformation. And this is a huge potential to digitize parts of the infrastructure. Of course, you cannot digitize the asphalt, that needs to be there, but a lot of the processes can be digitized. And we were together in a CEDAR-funded project called DROIDS, Digital Road Operator Information and Data Strategies, where we looked at the different roles that could be digitized. And a lot of them have a relationship with asset management and with current responsibilities that road operators have. So those current responsibilities can be shaped differently, more efficiently. And there is also a potential to have new roles. And one of those potential new roles is to facilitate connected and automated mobility. And this is through the mechanism or the concept that was previously described by Siddhartha, the DOVA principle, which we together developed in a other CEDAR-funded project. So it's great to see that that is being picked up in ISO standardization. But what is even more important is that it will be used in the future in actual testing and actual deployments. So if we can go to the next slide, and this is my final slide where I have some discussion points for the panel discussion and the Q&A. One of the things that I have seen in the past and that also make me ponder is the emergence of artificial intelligence for automated driving, where it could be seen as a blessing or a curse. And let me explain what I mean with this. The blessing is in the sense of the performance and scalability that I have seen. Quite impressive results by the likes of Wave and WeRide in terms of performance. I've been on the roads in Italy, in Paris, in Tokyo, in London, and I have seen really, really impressive performance powered by artificial intelligence, also end-to-end AI. But the curse comes here in the fact that you need to convince authorities to allow these technologies on the roads, and they have to understand the technology. And when things go wrong, it has to be explainable and transparent. And this is a challenge where we are also working on. And related to this is also the question, PDI or no PDI for CCAM. Although I truly believe that with externally sourced information, you can certainly augment CCAM performance. You see with some of the latest AI developments that that performance is less and less dependent on digital infrastructure and digital maps, for instance. So there seems to be different schools of thought, and this is something that we really have to discuss. Because for road operators, we have to take decisions on larger timescales. And as the saying goes, infrastructure is destiny. Once you have put it out there, it will be there for 20 to 30 years, as Professor Ran explained. Other points that are really important is to digitize the rules of the road. Currently, they are written for humans with superior contextual awareness, so to say. If you feed these rules to algorithms, you may have to be more explicit to get the outcomes that you want. And another one is also traffic management for automated vehicles. When you get more and more automated vehicles in the mix, you may have to do or rethink traffic management because it is different to do for algorithms than for humans. And this also has to do with the perspective for individual optimization versus collective optimization. But for all of these points, public-private collaboration is really key, also multidisciplinary collaboration. And we can discuss this further in the second half of the session. Thank you for your attention.
Thank you very much, Tom. Some very relevant questions there, which I hope we'll be able to devote some time to later, particularly regarding PDI. If I may, I'd like to welcome Ibon to the stage.
Thank you, Joanna. Well, I am Ibon Arechalde. I am the CEO at Asimov. Asimov is a company that is developing the autonomous road inspector and the autonomous urban inspector. And the presentation today is focused in the part of the evaluation of road markings, because we have seen in the previous presentations the potential of the connected vehicle, the potential of these autonomous vehicles, but really we have to consider that these vehicles have to use the physical infrastructure and just the same physical infrastructure that are using other users like the human users. No? So we will try to put the emphasis in this physical infrastructure that can be improved thanks to the digital information. In the next slide, we will see one example in the project that we have developed with Renault, the French OEM. We have discovered that in some cases, the lane keeping assistance system, this system that is trying us to maintain the lane where we are driving in a highway, is a system that sometimes fails due to the lack of good lines in the painted in the road. No, so really the problem is not the problem of the software or a problem of the high definition maps. The problem is a problem of this physical infrastructure because it's not correctly painted. If we go to the next slide, we will see different situations where really the digital infrastructure can have some information, but sometimes just in that point the human when he's driving, but also the connected vehicle and the autonomous vehicle has to solve some problems. No? In the first slide, if we click now, we can see bigger. In the first picture, you can see a place with the degraded signs, with poorly painted pedestrian crosses, with in a place just with a sewer, with irregularities in the pavement, with a protection that is not really a protection and that is broken. And in this case, well, this is in Spain, in a road in Madrid, and you can see the flowers that we put in Spain with when somebody has died in this place. Really, we cannot ensure that this infrastructure has caused the accident, but probably has not helped to avoid that. No? And when we discover these places is when we appreciate that with the digital information, we can prevent the problems and not wait to the accidents in order to say that this is a black spot. No, we can see this kind of previous black spots. The second picture, if we click now, we can see bigger also, and it's almost the same because we can see an incoherence between the vertical signage and the road markings. Really, we don't know why, but sometimes it happens, and in this case also, well, it's difficult to know how an autonomous vehicle could drive this road. All the problems are not only during the day. In the third picture, we can see during the night. In this case, it's a good place with lighting, but probably from our own connected vehicles, we can discover which are the places with bad visibility, with problems in the pedestrian crosses, with problems in crosses for bicycles, for scooters, for other things. So this can be analyzed also with these vehicles. And in the fourth part, that is a video, here we can see one example of a place that probably was not predicted that can have accidents, but really happened in the Basque Tour last year. And the problem in here was not the accident, because sometimes in the cycling tours they have accidents, but the problem were all the different objects just in the scape that did that finally the consequences of this accident were very heavy. And this is also information that we can collect from the vehicles. If we go to the next slide, that is the final slide, we can see how our autonomous road inspector is able to check all the condition of the pavement, the road markings, the safety barriers, the lighting poles, the traffic signs. And in this way, we can really check if there is a problem in the road, but also the problems that they can have outside the road when an accident happens. This is just the place where the accident of the cycling tour happened, but well, really, we passed it with our system after the accident, not previously to that. Clicking the last message is that this is not sci-fi. This is something that is already used by several entities, public entities. On the left, you can see the tenders of the Ministry of Transport in Spain, that they are already including the check by computer vision of the road markings, vertical signage, protection systems, and payments. On the right, you can see the tender of a city in Spain, also Las Rosas, that is also including this kind of evaluations. These are part of the contracts for maintenance. For the companies that have to do the maintenance, they are asking to them to put these kind of systems in the vehicles that they use in order to obtain this information automatically and in order to be able to prevent all these situations that can happen due to a bad maintenance of the traffic signs, road markings, and others. So, well, the idea It's very simple. We can use these kind of systems to improve the physical infrastructure and this improvement will be very good for the human users, but also for the autonomous vehicles. Thank you very much.
Thank you very much, Ibon. Thank you. Very relevant yet again, and also, yeah, some critical road safety topics there, certainly worthy of discussion. If I may, I'd like to introduce Jorge.
Hello, everyone. Hello. Thank you, Yona. Well, my name is Jorge Suarez. I represent ETRA I&D from Spain as a part of the ETRA group. Well, our mission is to contribute to the next era of CCAM by bridging research and real-world deployment. We think this is very important because roads are no longer passive assets. This means that they are becoming digital platforms, so that they need to interact with vehicles, with traffic management systems, and even with emergency systems. On the other hand, CCAM is not about connected cars. It's about creating an ecosystem where vehicles, infrastructure, and traffic management systems can cooperate each other. This is the next slide. So thank you. So, well, ETRA has been active in CCAM projects for several years, moving from research projects to real-world pilots. We mainly focused on 3 critical scenarios, as you see on the screen. First one is about the emergency vehicle management, making sure that priority and safe passage of these vehicles are doing it in safe way. Second scenario is about urban traffic optimization, trying to reduce congestions and emissions through AI predictive control. And on the third scenario, we try to protect vulnerable road users, mainly pedestrians and cyclists, because they are the most exposed in Spanish urban environments. So we present 2 European research projects, Podium and Augmented CCAM, that they have been presented they belong to the CCAM partnership that has been presented by our colleague Tom Alkin. So thank you. These projects happen in Spanish cities, Barcelona and Madrid, and in these projects, we try to demonstrate how physical and digital infrastructure can support CCAM. This includes equipment such as roadside units, sensors, and connectivity between the traffic control centers and the vehicles and vulnerable road users. So the main goal is interoperability. This means that the vehicles and the infrastructure has to speak the same language. And these pilots, well, are not theoretical. They are have done in operational environments where we have tested how CCAM interacted with the existing current traffic systems in these cities. Next slide, please. Well, let's start with the emergency vehicle. We agree that in an emergency, every second counts, particularly in urban congestion often delays the response times in emergencies. So our solution in these projects tries to integrate the human-machine interfaces inside the vehicles with the traffic systems in order to create dynamic ring waves along corridors. So when an emergency vehicle approaches, the system clears its route by adjusting the traffic signals and informing the connected vehicles that there is an emergency vehicle approaching. But this is not just about priority. It's also about coordination, because the system tries to communicate at the same time with traffic lights and the other vehicles to minimize the disruption to the emergency vehicles. So these demonstrations in Barcelona and Madrid show that this integration of CCAM into the urban emergency systems is based on cooperative systems can reduce the response times for these emergencies. For each scenario, you will see a diagram showing the scenario definition and how the vehicles behave with and without the infrastructures. These tests in Barcelona showed that the response times for particularly firefighters' vehicles, can be reduced. Okay, the next slide. Traffic congestion costs cities a lot of millions annually. So in this scenario, we use origin and destination data from connected vehicles and predictive AI algorithms to optimize flows in real time. By integrating CCAM data into urban traffic controls, we can dynamically adjust traffic signals and reroute the vehicles. This is a step towards the AI-driven traffic management, where decisions can be made on real-time conditions, not on historical or patterns from the past. In our experience in Barcelona was that these simulations showed potential reductions of 15% in travel time. So this has been fine for us. Next slide, please. Now, safety. Safety is essential. We all agree on this for sure. And this scenario is about protecting these vulnerable road users, mainly focused on urban environment, involving pedestrian and cyclists, but also e-scooters users. And in this case, you see that we have installed some cameras to detect vulnerable road users, but also to estimate their trajectories by using artificial intelligence algorithms. At the same time, the system receives the positions from the connected vehicles so that it can detect if there is any risk of collision between the vehicles and the VRUs, alerting both vehicles and VRUs about this risk. You see on the right slide, on the right side of the slide, the infrastructure installed in Barcelona, the cameras and the roadside unit, and the cabinet that contains the video local processor. And well, the VRU are detected but with a certain level of confidence. And well, the aim is to advance in this setting for different complex urban intersections, but also advancing on the cooperative fusion between the infrastructure perception systems and the vehicle perception systems. And finally, the last slide, please. So, well, our vision is clear, is to the physical and digital infrastructure that connects the vehicles and the emergency systems, traffic systems. And our next steps are focused on trying to scale up these pilots into citywide deployments, ensuring interoperability and public trust. And that's all. Thank you for your attendance. Looking forward to the discussion.
Thank you very much, Jorge. Thank you. Thank you. Yet another relevant presentation. Apologies. Thank you very much to all the speakers for those insightful contributions. We're now going to move into the moderated discussion and take a closer look at some of the topics. As we're running a little close to time, I'm going to limit it to one question per speaker, if I may. As such, if we have a look at the question answer section, yes, it's been a very popular session. We've had quite a lot of interest. That's fantastic. If I may, I'd first like to turn to Siddhartha. As you can see, Siddhartha, there are a number of questions directed to you. And I'm not sure if all of the attendees can see some of these, so I'm just going to give an overview. Obviously, it's mostly focusing on the question around whether automated vehicles are more of a hindrance than a help. Do they jeopardize safety or do they increase it? I'd love to hear your views on that.
Thank you, Iona, and also thank you to the individual who provided this question. I think it's a very pertinent question. I'll talk about it from two aspects. One is when they are being trialed in your cities, and the second one is when they're actually there for commercial deployment. In our experience, and over the last 12-15 years that we've seen these being trialed in these cities, you will always have certain issues as part of the trialing. And that's the whole point of trialing these technologies, to understand and iron out the issues that people might face during the course of the trialing. However, When it comes to commercially being available, where people are paying for these services, like in a robotaxi service, it is the responsibility of the national authorities and the local authorities to ensure the overall safety, not just of the technology, but also of the entire road ecosystem. And that's where a lot of effort is being put, especially in the European context with our type approval regime or type certification regime, is to understand what is the impact of each of these technologies on the other road users, the pedestrians, the bicyclists, the other vehicles around, and how do you ensure that it's not causing, not only from a safety perspective, but also not causing congestion or not causing or impacting a traffic throughput adversely. So all these considerations are being taken as part of the approval of this technology. And one of the key foundations of this is adherence to rules of the road for these technologies. So just like we as human drivers adhere to the rules of road, these technologies are supposed to adhere to the same rules of road. So I think that is something that all authorities are very cognizant of, and efforts and steps are being taken to ensure that there's no adverse impact. And that's when it comes to commercial deployment. However, during the trial process, we will see some of the issues, and they will be ironed out before they're commercially deployed.
Thank you for your comprehensive answer, Siddhartha. Yes, I think that's a very relevant point, as we have to bear in mind that we are, of course, very much still in a test phase with many of these pieces of technology. Thank you very much. Thank you very much for your time. If I may, I will now move on to a question directed to Tom. Likewise, short overview. What have you seen in terms of progress in digitalization in developing countries or continents such as Asia or Africa?
Yeah, so I mean, digital transformation is a bit broader topic than the one that I'm specialized in, which is CCAM. But to my knowledge, in Africa, you have Morocco that has several initiatives on becoming a digital hub for the region, and in Nigeria and Kenya, especially digital transformation in the mobile and ICT area are taking place. What you also see nowadays is there's a lot of focus on digital twins. And to my knowledge, in South Africa, there are several digital twin initiatives. And so for digital twins, that is building a digital representation of usually a city with several layers of information that have bidirectional flows. And this could be supported, or this could be supporting automated mobility, but much more, it can help in urban planning. And this is maybe something that Africa can use to sort of leapfrog some of the other continents in building, designing urban areas. So I think that is a opportunity for Africa. Now, as for Asia, there have been more automated mobility initiatives and thus also some digital transformations. Specifically in China, there is a lot of digital representation and digital twins going on. I was on a fact-finding mission earlier this year in April, so I've seen some impressive digitizations of Shanghai, for instance. Japan has long been working on automated mobility, so you see especially in Tokyo, but also in the rural areas, quite a lot of automation taking place. And then Korea and Singapore are front runners in Asia in this domain. And I would also like to mention the Middle East. So, for instance, in Abu Dhabi and Dubai, there are several initiatives that both link to automated mobility and digital transformation of the road operators. I hope this provides enough information. And if people would like to reach out to me, my LinkedIn profile or email address can also be provided.
Thank you, Tom. Also very comprehensive answer, and as you say, perhaps something to think about going forward. No, thank you for your time.
You're welcome.
Thank you. If I may, I know we have some answered questions in the chat, but I would nevertheless like to turn to some of those topics and maybe have the speakers cover them a little more detail and let them speak about their topic area. If I might turn to Jorge, the question regarding AI for traffic management. How do you feel about that topic with regards to normal road users and normal people going about their daily lives? How would they interact with AI in a traffic setting?
We use AI mainly for integrating it into the traffic management systems in order to optimize the routes for connected vehicles, but also for detecting road users. So, I mean, I'm not sure how this average common road user would be involved or particularly using AI in the daily trips. I mean, what we, from our experience, what we try to use is AI for in order to help users to understand the common traffic, the common situation, but also to alert them if there is any risk of collision, if there is any congestion that is along the routes, or if there is an emergency vehicle approaching along the route. So, I mean, the AI, at least from my perspective, should be now focused on helping these connected vehicles to manage in the daily traffic, not particularized to how they manage the AI in their trips. This is how I see it.
Thank you, Jorge. Yes, absolutely. I think it's important to differentiate between groups of users and what we're actually talking about there. No, that's very relevant. Thank you for your answer. Moving on the sort of sticking with the topic of reality and real life application. If I may, I would invite Ibon to respond to the question about vehicle-to-vehicle communication. Do you think that V2V is in a position to also provide sufficient protection to VRUs?
Yes, well, in this question, I see two different things. No, the first thing is that in this vehicle-to-vehicle communications, we have a problem in this moment. That is that each manufacturer, each OEM, is developing their own performance and their own functionalities and sometimes in different ways. So when you go and you take a brand of a car and you go and sometimes they are watching watching different traffic signs and reducing and increasing the speed of the vehicle depending on that. Others not. Also in the case of the lane lines, in some cases they are managing in a way, in others not. When you approach to a place with vulnerable users, sometimes they decrease the speed depending on the distance with these vulnerable users, but some of them yes, others not. So we have not a common solution in this moment on the floor, and each manufacturer is developing in their own. This is a problem because you can be safer close to a brand and not to others, and this is something that in the future has to be standardized in a way that and tested in a way that we can ensure that all the vehicles will protect the vulnerable users in the same way. But in any case, we have to understand that the real scenario in the real life is very, very complex. And it's very, very difficult for somebody that is programming the different systems in the vehicles to be prepared for any kind of situation that can happen in the real life. So we have to consider that these systems will help to improve the road safety, but it's very, very difficult to go to this point where any accident is avoided. So We have to go step by step, and I think that this is something that we have to take time, but also to try to coordinate the different manufacturers doing more or less the same functionalities, and also the communication between the manufacturers and the raw authorities in order to improve the infrastructure together.
Thank you, Yvonne. No, I see also the differentiation is critical there. Thank you very much. If I may, I will speedily move on to a question to Professor Ran. Bin, I know you've also provided a short answer to this question. However, we'd be really keen to hear more about your thoughts on the development of CCAM and why it's focused on very specific areas and not yet used in the wider community.
Okay, yeah, it's a very, very broad question. And the question itself has been evolving very different aspects here. So I think one of the core things here is why folks don't work together. Why CCAM is not happening in the way we want. I mean, especially for the last 10 years. So we do see the opportunity to come here. There are two ways of seeing that. Short answer is, we see new operators, either Waymos of the world or Ubers of the world, or maybe a new operator in the road industry will start to cut and piece from the vehicle industry, from the road industry, from the IT industry, and also from the AI industry to become a new operator. So that's where be a mentality change as we speak. We do see something is happening right now. For example, the right-of-way can be delegated to the government. And then they'll be focusing on the digital side of infrastructure. And also with that being embedded with an AI model, for example. And then we'll be going directly to the actual operators of the service providers of CCAM, for example. So it's a little bit complex. However, we start to see that's happening. And so that's answer part number one. Part number two is, and we need to change the mentality of everybody, especially the road operators. And we are very hard to change in terms of civil engineers. And so we're changed by years and decades. Not like the AI folks, we change it by weeks. So that's another part I say there's some final evolution coming, not revolution, at least in the US and in China and also in Europe as well. Yeah, thank you.
Thank you very much, Ben. Thank you. No, I can see that time is certainly a critical factor in the CCAM sector. Unfortunately, we're going to have to cut our discussion short there, as we've had so much to talk about. We've covered so much ground, but unfortunately, our time has run short. So a big thank you to all of our speakers this afternoon for their fantastic contributions, and for all of those who've participated and turned up from different parts of the world. I think that if there's one message that we could take away from today's session, it's that connectivity, automation, and safety are not separate ambitions. They are mutually reinforcing. As CCAM technologies evolve from AI-enabled traffic management to vehicle infrastructure communication, they offer a clear pathway to building road systems that are not only smarter and more efficient, but also safer, trusted, and more responsive to societal needs. The insights that we've shared today demonstrate that when digital innovation is paired with sound governance, robust infrastructure, and public engagement, roads can truly become enablers of a more connected, cooperative, and sustainable mobility future. So it's on behalf of the International Road Federation today that I'd like to thank you for being part of this discussion, and we look forward very much to continuing these conversations during the conference and as part of our programs worldwide. Have a lovely rest of the day.